It's time for our second lecture, 7.2. So in 7.2, we're going to be learning about how to name alkyl halides. And in general, we just follow the IUPAC naming rules and follow the 4 steps that we learned for naming alkanes, which are identify the parent, identify the substituents, number the parent chain, and alphabetically name each of the substituents, while keeping all of the numbers as low as possible. So that's why the top left one is 2-bromobutane, because its parent chain has 4 carbons, and the bromo group is at the 2 position. And the same for the other 2, where they are either cyclobutanes because they're a ring, or the halide group is at the 1 position. Alkyl halides are special in organic chemistry because instead of just talking about them as a functional group, part of their chemistry is defined by the carbons they're attached to and the carbons attached to those carbons. So briefly, any carbon that's attached to a halide group, we call that the alpha carbon in respect to reactivity. And an alpha carbon can be bonded, again, to 1, 2, or 3 carbons, which we call beta carbons. And if there is 1 beta carbon present, then we call the alpha carbon a primary carbon. If there are 2 beta carbons present, we call the alpha carbon a secondary carbon. And if there are 3 beta carbons present, we call that a tertiary carbon. This is going to play a big role in understanding the reactivity of alkyl halides, and it's good if you're acquainted with this terminology. Again, we follow the IUPAC rules whenever we're talking about naming alkyl halides, and you can name these things just like you were able to name alkanes in Chapter 4, where this molecule here would be, let's see, the H is in the back, and the priority is 1, 2, 3, 4, which means it goes clockwise, which makes that R, 1-bromo, 2-methyl cyclopentane. We knew that because we named the parent as a cyclopentane ring. We saw that there were 2 substituents, a bromo group and a methyl group. We were able to number the parent chain to make the numbering as small as possible, and we named them alphabetically and dealt with the configuration of that chiral carbon there. And alkyl halides are very useful in organic chemistry. The 2 main ways that they're useful are the 2 types of reactions that we're going to study here in this chapter. And that is in the reaction with nucleophiles, such as in this case where a bromine reacts with sodium methoxide to make this 1-propyl, or this propyl methyl ether and sodium bromide, as well as reaction with non-nucleophilic bases. These are chemicals that have no nucleophilicity or very little nucleophilicity, and so because of that, they just generate the double bond, as we saw in section 7.1, and this is shown in this reaction of 1-chloropropane reacting with sodium hydride, which is a non-nucleophilic base, to give 1-propene plus sodium chloride and hydrogen gas. So that ends our section 7.2. Stay tuned for 7.3.